God, hello and welcome to another section of software testing course. In this lecture we talk about some other concepts about software testing, such as coverage criteria, and again we talk about several activities in software testing process, in testing engineering, and so on. So the first concept we want to talk about is coverage criteria. To define some coverage criteria, suppose you want to be fully confident about the functionality, about the correctness of a simple method of your program. So look at this simple method, compute average, which we want to compute the average of three integer values, a, b, and c. As you know, each integer value require a 32-bit memory to save its value. So for each variable we have over than 4 billion possible values. To test this method with all possible inputs, we should test this method for every combination of three input parameters. And you know that all combinations is 4 times 4 times 4 billion of possible combinations. So we have over 18 octillion possible tests, and actually this is impossible. Really, when we want to do complete test or test by all possible inputs, this is impossible ever for a simple method. So even small program have too many inputs to fully test them all, and it is impossible to test to doing a complete test for ever simple method. So we should find a way to sampling this input space to find good samples, good inputs, good combinations of its inputs for doing tests, for test method. Which combination or which input is good for testing? Inputs which can find fault, the good input for test. So in software testing, we should find inputs from input space of a method that can find some fault in the method, can reveal the failure of the method. So as you know, input space might be infinite. What do you do when you're faced with the same method? What do you do when you're faced with the same problem? How do you sample the input space? How do you find the test values, the input values for testing? So we need a tool or tools to select suitable inputs for testing. As I said, the inputs which can find faults from the program method. And additionally, our test values should not overlap with each other. This means that each test input, each test case should test separate test paths and does not overlap with other test cases. So testers should search in a huge input space, and testers should try to find the fewest inputs that could find most problems, most software faults from the program function or method. To do this, we use actually the coverage criteria or coverage criteria. What's the coverage criteria? We define coverage criteria as an engineering process or collection of rules or structures which can be practical way to search the input space. For example, we can use some coverage criterion such as covering all program statements. This means in testing we should examine each statement of program at least once. We should provide inputs for our method which could execute each statement of the program at least once. Some statements may be executed more than that, but at least each statement should be executed at least once. So this is an example of coverage criteria, statement coverage. Statement coverage is a coverage criteria which helps us to find input values that tests the program, the method effectively. So we need some coverage criteria to search the input space thoroughly, but not test all possible input values. Just test a few input values with the aim of finding the most software faults, with the aim of revealing the most software failures. And the test inputs does not overlap with other tests. This means that each test case should be tested separate piece of the program or separate sections of the program, and does not overlap each other test cases scopes. So the coverage criteria is a tool that can help us to find better inputs, better combinations of input parameters of method to test the method thoroughly. Okay. So coverage criteria has several advantages, as I said. The coverage criteria could maximize the effectiveness, the performance of our testing. So maximize bang for buck. And moreover, coverage criteria can provide traceability from software artifacts to tests. What's the meaning of this phrase? Provide traceability from software to artifacts provide traceability from software artifacts to tests. How you notice this sentence? This means that we could find the tests for any part of our software. This means that we can navigate from design models to related tests in collection of tests that we have generated. We could navigate from source code to the related test cases of our test set. We can go from requirements to related tests that design to testing that requirement, the special requirement, the specific requirement. So in traceability, we can walk through design model to source code, and from source code again to test cases. And we clearly will know what test case is related to a specific piece of our program or our design model. Which test case is generated for testing each part of the model, or which test cases is generated for executed which test cases is generated for testing some piece of code. What's the set of test cases to test a specific method? Because when you want to test software, you generate many test cases. Your test set is very big, and you should know what test cases test any function or any module of your software. When we use coverage criteria, the coverage criteria can connect source code to the test cases, can connect requirements or functionalities of intended for the software to test cases, and connect design models to test cases. And obviously, it's clearly could be detect which test case tests each model, each method, each functionality of the system. Okay, another advantage of coverage criteria is regression testing. You can make regression testing easier, because by the coverage criteria you clearly could connect a piece of code to its related test cases. As I said in previous advantage, as a result of traceability advantage of coverage criteria, we can make regression testing easier, because we could detect which tests should be executed for testing each part of the software. In regression testing, as you know, we test the part of the software or parts of the software we change during the maintenance process. And it's not necessary to execute all of our tests again. This could be very costly. To avoid to doing costly work, we should just execute it a special part of our test. Some test cases that is related to the changed piece of software should be executed again. Okay, so by the coverage criteria, we could make regression testing easy. Another advantage of coverage criteria is that we have a stopping rule. What about a stopping rule? What's the stopping rule? As you remember in the first section of the course, I asked you how much tests should be done to be confident about a software product. When we stop testing a software product. In that days, we have no answer to this question. But today, we could say that we go on testing, we continue testing until a coverage criteria is covered as much as possible. So the coverage criteria could define a stopping rule for stop the testing. It helps me to do not much tests. We do just tests as it is needed. The extra tests would not be executed, and we save our money and just doing an effective set of tests and executing an effective set of tests. This means that we try to find the fewest amount of tests for finding most software faults of the program. And we have a stopping rule. The rule is that all test requirements extracted by a coverage criteria should be covered by our test cases. Okay. And the final advantage or last advantage of coverage criteria is that it's possible to produce software tools to support generating of test cases automatically. If we have an engineering tool, means for generating testing automatically, we could produce software tools for doing testing, for doing automated testing, for generating tests automatically. So the coverage criteria can be well supported by powerful tools. Okay. But what's the relationship among test requirements and coverage criteria? What's the test requirement? As we have defined the test criterion as a collection of rules and a process, an engineering process that define test requirements. So test requirements is the result of using a test criterion. Each test criterion could define a set of test requirements. For example, if our test criterion is a statement coverage, this criterion defines all statements of the program as our test requirements. So we should cover every statement of program. This means that every statement of the program should be executed in testing process at least once. So our test criterion is statement coverage, and our test requirements is the set of all statements of the program. Or when our test criterion is a functional requirement, this test criterion defines all functionality of our software system or software product as requirements of testing, as test requirements. So we should cover every functional requirement at least once. We should execute it, we should examine each functionality which is stated in requirement document at least once, and every functional requirement should be covered. So we define test requirements as specific things that must be satisfied or covered during testing. Specific things, for example, statements of the program, for example, functional requirement, logical expressions such as if conditions of if statement should be covered or satisfied during testing. So for this test requirement, we say that each statement might be a test requirement. It might be a test requirement. Or each functional requirement for the second test criterion might be a test requirement. Why we say might be? Why we say might be? Is there possible that a statement could not be a test requirement in a statement coverage? Yes. We see this later. Some statements are not feasible test requirements, and they are impossible test requirements. They could be impossible test requirements. So we could not cover impossible test requirement. We talk about this in the next slides. So how many test criterion are there in software testing? As stated in this box, testing researchers have defined dozens of criteria, but they are all really just a few criteria on 4 types of structures. There are hundreds of test criteria in the literature, but most of them are the same actually. For example, as Professor Afut said, there are 14 test criteria, which all of them using the same structure as graph coverage, named graph coverage. So in this book, the 4 types of structures are introduced to initiate all type of test criteria, to define all types of test criteria. So also, we have several hundreds of test criteria in the literature. All of them could be categorized based on 4 types of structures. So in this book and in this class, we explain these 4 types of structures in 4 separate chapters of the book. These structures include input domains, graphs, logical expressions, and syntax description. Each of these structures would be covered in a separate chapter. And we talk about these structures in the next slides. But what about the categorization of testing activities and testing strategies in the software testing literature? There is an old view in software testing literature back to about 10 years ago. The testing categorized as black box testing and white box testing and gray box testing or model-based testing. What's the black box testing? Probably you are familiar with black box testing. Then we did not have access, we don't have access to the source code of the software product. We should define our tests just related to input and output behavior of the software component. We should just count on the specification of the program method, and we cannot see the internal structures or the body of each method of the software product. But we know about the functionality of the software product according to requirements documents. So in this situation, we derive tests from external descriptions of the software. We derive tests from specifications that provided in the requirement document. including the specifications, requirements, and design models. We just have access to design models, requirements, and requirement analysis documentation. And we have not access to the source code of the program. So in this case, we could not define coverage criteria related to the source code of the programs. We could not use testing strategies or testing techniques, test design techniques that uses the source code as a source of or origin of test generation. But on the other hand, when we have access to the source code, we could use those software testing strategy or test design techniques which uses the source code coverage criteria, source-based, code-based coverage criteria. In this view, we derive tests from the source code, internals of software. We can see the internal structures of the software. Especially, we can see branches, loops, and other structures and other internal structures and statements of the software product. So the techniques that could be used for white box testing is different those of black box testing. As you know, in the literature, sometimes we don't have access to the source code, but we can have several models of our products, several specifications, especially formal specifications of the behaviors of our software product. In this situation, we could have make a gray box testing or model-based testing, in which we cannot see the internal structures of the software program. We cannot access to the source code of the program, but with a higher level of abstraction, we can have access to the models, the activity diagrams, the state chart diagrams. As you know, they can describe this internal structures of the program. Indeed, we see the internal structures of a program blurred. So we say we can do gray box testing. In gray box testing, we drive tests from a model of the software, such as UML diagrams, such include activity diagram, collaboration diagram, sequence diagram, state chart diagram, or other models such as formal models that specify the behavior of our software product more formally. And we can use techniques, special techniques in this case, to design test cases. As I said before, in this lecture, we use a new approach called NDTD, stated for model-driven test design, which makes these distinctions less important. The general question that exists in this case is that from what abstraction level we drive tests? Even if I had access to the source code in model-driven test design, we try to design tests from a higher abstraction level. We raise the abstraction level of test design. Because, as you know, the source code has more and more details, and when we stuck in details, we could not produce test set effectively. Our test set probably has low performance. So in this approach, the approach that our textbook focuses on is model-driven test design, which tries to raise the abstraction level of software specification and use the same techniques for all these categories of testing. We explain these techniques with more details in next slide. As I remember, I think that we find test design for you, but in this slide, the test design is defined again. As you know, test design is the process of designing input values that will effectively test software. Designing, generating input values, sampling input values from input space. As I said before, in software testing, we should examine a huge amount of input values to test thoroughly, to do complete test. But in software testing, this is impossible. We should define a fewest number of test cases to test a software functionality. So in test design process, we try to find the fewest input values that could reveal most program faults, which we will say that it effectively tests software. But you should know that test design is not all activities of software testing, but test design is just one of several activities of software testing. We have other testing activities that we will explain for you in this lecture. And you should know that test design is the most mathematical, the most technical activity in software testing. And most challenges of test engineering is in test design activity. In this slide lists all the activities, the main activities of test engineering, which consists of 4 general types of activities. The first one, and the most important one, is test design, which could be done by 2 approaches: criteria-based approach and human-based approach. We talked about criteria-based approach in the previous slide. In this approach, we have a test criterion as a means that help us to search cited the overall input space. This could prevent us to search blindly in input space. If we test, we select inputs from this input space randomly, actually we search blindly in this input space. And this could not be effective. This could not lead to effective set of test cases. But if we select inputs more cleverly, we could find set of test cases that reveal the most problems of the software tests. For this, we need a criteria or criterion. The criterion is singular, the criteria is plural. On the other hand, we could use a human-based approach. In human-based approach, we need to work with some experts of the users, from the users people. They know what behaviors are needed for special cases in their business. So in human-based approach, we could not use a mathematical technique or engineering technique, but just we use the experience of the most expert users of the software product to test the software product. So as you know, the test design activity try to sample a subset of our inputs from input space to test the software product. But in another activity named test automation, we try to generate test scripts to execute tests automatically, to generate tests automatically. And we try to decrease the cost of testing by doing that automatically. There are several techniques that could help us to do this. The test execution activities tries to observe the execution of program for each input, for each test case. And when we compare the result, the behavior of the execution, the actual execution, with the expected one, we just evaluate the results of the test. So in test evaluation activity, we compare our observation from the execution of software for each test case with the expected behavior which described in the requirement document, which is specified by the design models, and we evaluate that each test case is passed or failed. When the test case is failed, we should check again the test or the software program. Both of them should be checked because it's possible that the test is wrong. The test could be wrong, or the expected result could be wrong in our specification. So in test failure, we should check both the test and the artifact and the program. So as you probably know, and you thought from our explanation, that each type of these activities require different skills. As I said, the test design is the most technical activity. The engineer who works in this activity, on this activity, should be familiar with programming. He should be expert in programming, in coding. He should be expert in mathematical structures. He should be more clever and more experienced in software design activities. But who work in test execution, you just need some simple skill for executing each functionality of the program and feed the programs with the input values designed in test cases and record the result of the execution. And this needs least skills or science of coding and so on. So each type of activity requires different skills, different background knowledge, and different educational training. The last phrase stated that no reasonable software development organization uses the same people for requirement, design, implementation, integration, and configuration control. Why? Suppose in testing activities, in testing, software testing, we use a test designer to execute, to execute tests. this activity is very boring for designer, test designer. In this activity, they could not use their expertise, and it would be more boring. On the other hand, the company should pay more money for test execution. Instead, the company can use amateur person to execute tests with least skills. The expensive persons just should be work on special activities such as test design. If they occupied by test execution, we should pay more money. It would be more costly for our organization. So it's not reasonable. We try to decrease the cost of testing, but if we assign activity to our staff run, this could lead to more costs. This box asked why do test organizations still use the same people for test activities? Why? Because the test engineering is at the first and initial stage of its experience, and some organizations do not know this point, and they should pay more money. They increase their costs of testing. This clearly wastes resources. Okay. In next slides, all of these activities are explained. The first activity, as I said, the test design, which design test values to satisfy coverage criteria or other engineering goals. As we will experience these techniques in the later of the book, especially 4 chapters of the book cover 4 structures that support all coverage criteria in the literature. So this activity is the most technical job, as I said, in software testing, requires knowledge of discrete math, programming, testing, and require much of traditional computer science degree. This is intellectually stimulating, rewarding, and challenging activity. And test design analogous to software architecture and development side is the same, has the same importance. And even we using people who are not qualified to test design, we have a bad consequence, and surely we get ineffective test sets. we just waste budget, we just waste resources. In a human-based test design activity, we use domain experts, design test values based on domain knowledge of program and human knowledge of testing. This is much harder than it may seem to developers, because the expert users should have slightly skill in programming logic, in programming the structures, and they should guess what inputs could fail the software. So this is hard, but this is done by expert users, who knows the domain of the application. This technique or strategy requires knowledge of domain, testing, and user interfaces. And also require almost no traditional computer science degrees, but a background in the domain of the software is essential. An empirical background is very helpful, or logic background is very helpful for doing human-based test design. It's also intellectually as stimulating, rewarding, and challenging, as we said in criteria-based test design, but not to typical CS majors. The second activity, as I said, is a test automation, which embed test values into test scripts, into executable scripts, which is a piece of code that can execute the test and record the results. This is a routine activity. This is slightly less technical and requires knowledge of programming, simple programming skills is needed. Requires very little theory and often requires solutions to difficult problems related to observability and controllability. We talked about observability and controllability in previous lectures, and we talk about this again in next chapters. Because who want to program test scripts, he should call each methods of the program, of the software product, and he should save the results in some temporary variables, and he would compare them with the expected results. So the observability of the program could help the generation of test script. And this is also important in controllability. Of the program. This activity is a simpler activity than the test design, and this can be boring for test designers. Programming is out of reach for many domain experts. Many of domain experts could not program well. So in human-based test design, we should assign the activity of generating test script to other people who could program, who could generate test script for tests that is designed by domain experts. But there is a question that who is responsible for determining and embedding the expected output? Who is responsible? I think the test designer, as I told you before, the test designer, when design a test case, he should provide a test input values, prefixes of the system, and expected results, and postfixes. So, a test case, as I said before, has 4 parts. One of them is the expected output. So, the test designer should provide the outputs of each test case, and who want to automate test execution should embed the expected output in his or her test script. So test designers may not always know the expected output. When the test designer don't know the expected result, what should I do? In this situation, the evaluators may be in users of the software product, need to get involved early to help with this. The domain experts should be present for helping the test designer, helping to test automator to guess the expected result. Okay. Test execution is another activity of software testing, which in this activity we run tests on software and record the results. This is easy. This is not technical. Requires basic computer skills such as ICDL. Interns could do this activity. Employees with no technical background. Asking qualified test designers to execute tests is sure way to convince them to look for a development. But using qualified test designers for test execution is costly decision. If, for example, GUI tests are not well automated in today, we could automate even GUI tests, means graphical user interface tests. If you want if you want to know how this could be done in industrial, you could search about the Selenium tools. For example, in testing the web application, we could use the Selenium tools, which can connect with our browser to load the web pages and feed it its forms and boxes of data with appropriate inputs from our test cases, and execute and push buttons of the web page automatically, and you can see the results, and the Selenium could extract the results fields, and you could compare the results extracted from the web page in your test script. So in industrial, we can execute automatically our test cases over the website, even for testing GUI, graphical user interfaces. But if GUI tests are not well automated, this requires a lot of manual labor. And several persons should sit down and execute our test cases, and this could be very error prone, because humans could make mistakes about when recording the results, when reading the results, when feeding the executions with correct input values. If we done this activity manually, it would be error prone. It's better to be fully automated, and this is possible today in industry. As a exercise, you can search some tools such as Selenium, such as TestNG tool, such as I remember. There are many tools for this task, even for testing GUI. And the last phrase points that test executors have to be very careful and meticulous with bookkeeping. They can make many mistakes and leads to software failure decision or fails test executions. So they should be very careful in the execution of our test cases. The last activity, as you know, is the test evaluation, which evaluates the result of testing and report to developers. The first statement says that this is much harder than it may seem. Why? Why? This is hard. This seems very simple. We just evaluate results of testing and report to developer. Why this? Like said, it's hard. You should know that this activity requires knowledge of domain. People who want to evaluate test cases should be familiar with domain experts. I'm sorry. Excuse me. This task is hard because you need to know to be a domain expert. You need to know the testing strategy. You need to be familiar with interfaces of the program and psychologies skills. Usually requires almost no traditional computer science skills, but a background of the domain of software is essential. An empirical background is very helpful because you should connect the result of the test execution to its inputs and compare with its expected results. As you see in the previous slide, in some cases the expected result is ambiguous and is not clearly defined in the test case. In these cases, we need to know about the domain of the application. So, on the other hand, in human-based test design, you should be familiar with psychology skills to guess what inputs would be better, would be find a new faults of the software. So this skill is rather harder than it may seem. There are other activities in software testing. As you know, it's usual in software engineering development life cycle, as you experience in your works. There need some activities such as test management, test maintenance, and test documentation activities analogous to software development lifecycle. We have needed these activities also in software development, in other phases of software development. So it's obvious for you, and I don't explain more about this few slides. And the organization of the team is important in software testing, but I try to explain more technical things, or more technical concepts in this lecture, and we do not waste the time for this general subjects. You could study the book yourself for these concepts, and more of them could be gained by experience when we work in a testing team, we gain the true rules, the correct rules in management, in psychology, from social, emotional skills to do better, to manage better our testing team. So in applying test activities to use our people effectively and to test effectively, test software product effectively, we need a process. We need a process that lets the test designer to raise their level of abstraction, which is the goal of the MTDD approach. The goal of MTDD approach means the goal of model-driven test design is to raise the level of abstraction. In this approach, we try to extract some models, some structures from software artifacts, say source code, to define software requirements according to our extracted structures, and define ways to cover that requirement. I think this is enough for this lecture. I will explain you soon the MTDD approach in separate lecture. In the lecture we talk about just model-driven test design and no other concepts. So I will do this soon for you. Have a nice day, and see you next session in the class for answering your questions about the previous lectures and answer your questions about your study project. I will hold the next session online, and I hope I see you in that session.